All right, hello everyone. Thank you for coming. Here's the slides if you want to see them, and you don't need to grab it now. You can wait till the end and see if the talk is worth it, and grab this QR code at the end too if you want. So I'll get started. I'm going to be talking about the Angular Renaissance and 4 key new features that have come up in the last few years in Angular. And who am I? I'm Lance Finney. I'm a software developer with a Swiss-American company called Infocon, and I'm an Angular Google developer expert in Angular. And I'm really thankful to the sponsors and to everyone else for inviting me here. I've actually been to Porto before. 6 years ago, I taught a class on Angular for 3 days for a company called Natixis. Anyone here from that company? All right, anyway, but I loved it then, and I was really excited to be able to come back this time. So I'm going to be talking about Renaissance, which means rebirth. And if you're going to talk about something reborn, it's kind of useful to know what is reborn. So a brief history of Angular. It was created in 2010 as AngularJS. And a little bit after that, Google took it over, and it was a big deal in the web development area. It was the first really big single-page application framework, and it really led the ecosystem for a while. However, the core team at Google realized that there were some core architectural problems with AngularJS, so they decided to fix them. And the approach they took was to start from scratch and create Angular. And they did more than just change the logo and drop the JS. It was actually an entirely new framework, just had the same name. And that was a mixed bag. It enabled them to go to the brand new thing, but there was no real transition process from the old way to the new way. And so the Angular community lost a lot of people who said, as long as I have to start from scratch, let's try this React or Vue or whatever. But those of us like me who stuck with it got a much, much better framework than we had initially. Unfortunately, again, they realized that there were some core architectural problems. But they learned their lesson, and they didn't start over from scratch, but they rewrote the compiler and the renderer while we were all using it. And it's a really big technical achievement. It's kind of like replacing the engine of an airplane while it's in the sky. But the downside is while they were focused internally on what they called Project Ivy, it meant that we didn't have a whole lot of new features that excited us for a while, and Angular felt stagnant. The promise was that with the new features, with this Project Ivy, we would have a lot of innovation eventually, and that did come true, and that's what we're seeing now. And when Angular 17 came out 2 years ago, there were so many new features, there was a lot of excitement, and there was so much new that they decided to change the logo, and people started using the phrase Angular Renaissance to talk about how it was becoming interesting again. And people were talking about it well on Twitter in a way they hadn't for a while. The latest version of Angular is 20.3, which came out last month. Version 21 will come out next month. So now with that background, we're going to talk about this that's almost all I know, and will be helping us with this. So first, we're going to talk about standalone components with Raphael. So what changed here? Angular was weird. Among all the frameworks, Angular was the only one where the component was not itself a compilable standalone unit. When you wrote a component, you had to register it in this other module file. And if you have any dependencies in your component, you don't tell that component about it, you tell this other file, this module file about it. And it was just kind of weird. It worked, but it wasn't great. But now components are their own modules. They truly are standalone, which is simpler to think about, but it gives us some other advantages too. So here's an example of a component that Raphael put together. On the left, we have the non-standalone version, and on the right, we have the standalone version. And I'm going to be looking at this component a lot, So I'm going to talk about it a little bit. It's the sewer component representing the turtle's sewer. And there's very little state here. The only state is whether the manhole is open. And here we're starting it with closed. And near the top, we say, if the manhole is open, then we will show a welcome. But if the manhole is closed, we don't show anything at all, except there's always a button. And we can click the button to open and close the manhole. And the button will either say close manhole or open manhole, depending upon what action the button has. Simple component. And on the right, you see the changes for standalone. It's the line that's highlighted and the line below it. This highlighted line is a line that says this is standalone. And that's what we needed to do initially. We don't actually need to do this anymore. It is now the default, so you don't have to say standalone, but initially when they created it, you did. The more interesting line is the next line, declaring that this component imports ngIf and the welcome component. So we have that if in there. If the manhole is open, show a welcome. We have a dependency on those two components, so we are declaring our dependency right here within the component. So you can see there's not much that actually changed in the component, except we added a bit. And usually in programming, we're trying to do less. So is it good that we added a line or two of code? And the answer is yes, because adding 1 or 2 lines of code enables us to get rid of entire files everywhere else. So what file did we get rid of here? It was the ng module. So this is the sewer module that contained that sewer component. And you can see in the decorator near the bottom, it declared that it contained the sewer component and the welcome component. The sewer component can't live in the old way without being in a module like this. And by having both these two components, the sewer component has access to that welcome component, and so that's how that dependency was set up. So that's this welcome component part of what's in that new declaration. The other part was the ngIf, and that came in on the common module. And that was something we would declare for most modules so that Angular components could have access to things like ngIf and other really basic things that just weren't always there. The other part that we had in this module was routing. When we routed to this module, at the top it said, when we get here, show that component. And that was not anywhere in the sewer component. So where did the routing go? The fact is we just don't need it anymore. And the trick with standalone components is that most of the work that you have to do to understand standalone components has nothing to do with the components itself. It's with bootstrapping your application. So here we see the bootstrapping for this simple application. On the left, the old way, on the right, the new way. I guess I did my hands backwards, sorry. So in both cases, this is where we do our true bootstrapping, but the APIs are different. In the old way, we use something called Platform Browser Dynamic to bootstrap to a module, to bootstrap to the app module, the overall application definition. And you can see near the bottom, we had a second level of bootstrapping from that module to the component. So main to module to component. On the right, you see we now use a different API, bootstrap application that goes directly from main to the component. We just don't use the module anymore, it's extra. And the other part of it is the routing. Before, we used router module to route from the root to the sewer component, or sorry, sewer module, which is what it's declared here. And then in that other file, it said, when you get to the sewer module, go to the component. You can see here now we load the component directly. We go from the root to the component. So that whole module that was necessary as another layer to hold the component is just completely gone. And in my opinion, adding one line to the component to get that entire file and that complexity and that mental model is completely worth it. And in fact, it's in the modules like this, the root modules, which is now not a module file, but a config file. This is where the complexity comes in when you're converting to a standalone component application. The components themselves are easy, but things like router module for root becoming provide route, there's a lot of changes like that where the APIs have changed for the new way, and that's where you're actually going to have to work. And this is actually what they really wanted for Angular from the first place. When they created Angular 2 on the rewrite, this is what they wanted. I was in the Angular community then. In the alphas and the betas and the first release candidates, there were no modules. Components declared their own dependencies. But in a very, very late release candidate, they realized there was a corner case with some dynamic components that could not work with the way they had it at the time. So they had to create modules, and they created it for all of our components, and they kind of pretended that it was the idea they wanted, but they never wanted that in the first place. But with Project Ivy, they can do it now the way they wanted to in the first place, and this is a much simpler model. The status of this was introduced several years ago in Angular 14 and 15. It was the default for new components by 17, so 2 years ago. And now it is truly the default. You don't even have to say that you're using it. It's assumed. And there's a link here with schematics that you can run to help change your application. It will change most of your components, but a lot of the providers you'll have to figure out yourself. So that was number one. Now we're going to talk about the new control flow with Leonardo. And here, we're going to see how if has changed. And we have pretty much the same component we had before, but there's a new line. After the welcome, we have an else. So we say, if the manhole is open, we'll show the welcome. Else will show closed. So what does closed refer to? It refers to somewhere else in our template file, there's going to be an ng template with a hash closed. And whatever inside that is what we'll see. So if the manhole is open, we'll show the welcome component. If the manhole is closed, we'll show stay out. And that worked, but it was weird. It's the only programming construct I've ever seen where if you do an if you do an if, it's inside the thing that is controlled by the if. And the else is referring to this thing that's, this hashtag somewhere in your file. It could be anywhere in your file. So it worked, but it was weird. The new way is on the right. If manhole open, show the welcome. Else, stay out. Anyone who knows any C-based programming language can read that. Now, there's a little bit of a weird syntax with the @ sign, and that's just necessary to escape, just to tell the compiler that we're doing this particular thing. But other than that, it just reads like programming. So much better. Also, what if we have an else if? In the new way, it's easy. @if, @else if, @else if, @else. Great, no problem. In the old way, we would have to put another star ng if inside that ng template to have another ng template, who knows where it is in our file. So we essentially had these weird go-tos everywhere. Also, if you look at the imports, we used to have to import the ngIf, because ngIf isn't always there, but the @if always is, so we don't have to import things. So it's just a lot easier to read. For loops are kind of similar. The turtles love their pizzas. So we're going to loop through our pizzas, putting a star ng4 on our list element, on our bullet, to show every pizza. We'll grab the index out, and then we'll say 1 sausage, 2 pepperoni, 3 cheese, whatever. And if there happen not to be any pizzas, we'll use an ngIf to say bummer, because we really do like our pizza. The new way, it's a for loop. @for, every pizza of pizzas. We know how to read that. Oh, wait, okay, track, I'll come back to that. That's weird. Ignore that for the moment. But then within that for block, we have the thing that we're looping on, which is normal. So within that, we can grab the index. $index works within that scope magically. You can also do $ first, last, even, odd. But we can grab that index and then see our 1 sausage, 2 pepperoni, whatever. And then optionally, we get for free this @empty. We don't have to do an extra if. If there's nothing in that loop that we're looping over, show bummer. So the empty is a little bit different than a for loop, but otherwise it just reads like a for loop. But oh yeah, there's that track. What is that? That's actually a really important thing for performance. So imagine we have a list of 50 pizzas that is sorted alphabetically. And it's a list that the users can change. And they decide to change their sausage to Italian sausage or chorizo, whatever. It's going to go to a different spot in the list. If we don't have track, Angular is going to look at that and say, all right, well, we used to have sausage here, and now it's moved, but I don't actually know what moved. I better just re-render everything, all 50 of them, just to be safe. What track does is we can say what is a unique ID for each element in there, so it can know the sausage that is, this thing that says Italian sausage, it's the same thing that was the sausage before. Re-render that one, because that one has changed. And the things that it got moved around, those are the same things as before. They have the same ID. I don't need to re-render them, I just move them, which is simpler for Angular to do. And the ones that didn't get moved, I don't have to do anything at all. So instead of 50 renders, it's 1 render. It's much, much better for performance. And we used to be able to do this in the old way, but the syntax was weird, so almost no one did it. Plus, the performance is better now. It's a better algorithm, so they made it required. If you're doing a list where the user can't change anything, it's just visual, you can say track by @index. That's fine. But if you're doing anything where the user can modify things and you want Angular to have good performance, track by something that is a unique ID. The last part of this general feature is switching. So we're going to switch on color. And the old syntax, again, was weird. Okay, so we need to use square brackets on an ng switch to say what we're switching on. And then each case in there is going to use the star structural directive for the ng switch case. So, all right, purple is Donatello and blue is Leonardo, etc. And then we have another star structural directive for the default to look at Splinter. And again, it works, but again, it's weird. Now, @switch color. Case purple, boom. Case blue, boom. Case default, boom. It reads much more easily. We don't have to import it. And we had to import the 3 different things last time, one of which was the square brackets and 2 of which were structural directives. Now they're all the same type of thing. We don't have to import them. It's easier and it reads better. Sure, it's more lines of code, but I would much rather look at what's on the right. And it's also type safe. If we try to pass something that's not a string into color, we'll have a compiler error. In the old way, it would just go to the default. No type safety there. So overall, with this change, you have fewer imports, which means smaller bundles, better performance, especially with track, better type safety with your switch, easier ergonomics because it just looks like code, and there's easy migration from the old way. And this kind of matches what the other frameworks had. Angular was weird in having these structural directives, but Svelte had the hash if, and Vue had the v-dash. It's basically the same type of thing, but they have slightly different syntax. So Angular's kind of caught up here. And this was in developer preview in 17, stable in 18. The old ways are deprecated, and they'll probably be removed next year. So use the schematics, which are really good, and make sure you're using the new way. Next, we're going to talk about deferrable views with Donatello. And this is the first thing that I'm talking about that's not just a better way of doing what we could always do before. This is actually something new. And it's not just new for Angular, it's really new across all the frameworks. It's not entirely new by the concept, though. What this is it gives us lazy loading by component. And we've had lazy loading in Angular forever, but it was always lazy loading at the route level. So if we go to the admin page, everything on the admin page gets loaded at that point. And then if we switch to, I don't know, the shopping cart page, everything in the shopping cart page gets loaded. But what if on that shopping cart page, at the bottom of the page, there was a really heavy component that we didn't want to load unless the user scrolled down and put it into view? We couldn't really do that before. There were some hacky workarounds that got close, but not really. Now it's easy. And it works with standalone components. I'll show how in a moment. So this is the basic syntax. This is a lot more than you need by default, but it shows everything that we can do. So we have @defer, that same that we saw for if and for. And in the block controlled by @defer, those things, whatever is in there, will be hidden from view until a trigger gets executed. In this case, the trigger is on idle, which is the default. I don't have to say it. There are other triggers as well, but that's the default. So this means that the two components, app idle and app non-standalone, will not be visible until that trigger. The difference is that the one of those that's really a standalone component won't even be in your browser until the trigger happens. Whereas the old non-standalone component will get part of your initial bundle. And so it's not truly lazy loaded, it's just kind of hidden with a fancy if. So this really works well with standalone components. So in this case, idle means the browser is not going to load this from the server until the browser is done loading everything else. So just wait a bit, wait till everything else is taken care of, then we'll bring that in. So what do we show until that happens? That's what we get with the optional placeholder. So we're going to say this placeholder will go away after 2 seconds. And where that 2 seconds comes from is the optional minimum of 2 seconds. We're going to show this placeholder, even if we don't need to, for 2 seconds. Why would we do that? Because otherwise it might show for a few milliseconds and your users will just see something flash on the screen and they'll wonder what they missed and they'll be annoyed. So put it on the screen long enough so that they know what's happening. It's optional, you don't have to do it, but that's the idea behind it. And then once loading has actually started, once the trigger has been invoked and we're loading, we have another placeholder called @loading, which here we'll show for 1 second. And then if there's some sort of error in loading this in lazily, we have yet another placeholder that we can show. Now I mentioned on idle is the default one. There are several. There's on idle, on viewport, on interaction, on hover, on immediate, on timer, and you can build your own. And I'm going to show these live now. So this is an application that is part of the curriculum for a company I used to work for. Like when I was here in Porto before, it was working for this company. But I created this part of the curriculum, so I think it's okay for me to use it, even though I don't work there anymore. But this is showing this application that has a trigger here. So I'm going to reload it here. And you can see, I'll do it again, this placeholder will go away after 2 seconds, and then boom. But the important part is this right here. This is a separate bundle just for the idle component. There are actually 2 components in there. One of them is standalone, one of them is not. The one that is standalone has a separate bundle. And that only comes in when the browser is done with everything else and has the time to work on it for you. The other one is part of the initial bundle. So use standalone components with this. Now, this is such a tiny toy app, you can't really see the advantage of it. So let's go look at some of the other triggers. There's viewport. So here I have a scroll box. And if I scroll down to the bottom, once it comes into view, this component was loaded from the server. So that's the example I said, that if you have a really heavy component, you only want if the user scrolls to it. Now you can do it with just a couple lines of code. We have interaction. So right now, nothing has come in for this. But when I click on this text, which is a placeholder, brought it in from the server and loaded it immediately. And you don't have to have it on itself. You can also have another button be the target. So I can click on this button to load what's below it. So you can have controls in different ways. It didn't have to load it again a separate time from the server because it was already in the browser, but it didn't show it until we used it. And showing that same basic concept in the other direction, we have on hover. So if I come over here and carefully, well, I hover over this, nothing happens, but I hover over the target and that brings in the hover component, or hover over the other placeholder and they come in. Can have immediate, it will bring it in immediately. I don't really understand why you would do this instead of just having the without the defer, but it's there. You can do a timer. 1, 2, 3, now we're loading. 1, 2, we got it. And you can create your own triggers. So I have a manual trigger here. This value down here is the placeholder. But when I increase that value to be above 3, now loading for 1, 2, we have our value. So a nice new feature that we have that we just did not have at all previously. This was in developer preview in 17, stable in 18, and because it uses that at syntax, the same as the if you're using Prettier, you'll have to make sure you're on a relatively recent version of Prettier, because otherwise Prettier will have no idea what you're doing. The rest of the talk is going to be on signals. So Michelangelo gets to dominate here. So what are signals? It's a new synchronous reactive primitive. And I put new in quotes because it's new for Angular, but the idea has been around in programming for quite a while. It hasn't really been on the forefront of any frameworks until Solid brought it in, but Solid was not very big. And then when Angular took it on, people really took notice. But it's also a concept that you've kind of seen before. Now, I'm sure we've all done a spreadsheet, something like this, where in this case, it's calculating the cost for a number of guests. But I'm sure we've all done something tracking our finances or whatever, where there's some input numbers at the top and they all get calculated and there's a calculation at the bottom that gets updated immediately whenever any of the inputs change. And that's what we're going for. We are looking for a way for our framework to know how to reload, repaint, refetch from our state management immediately whenever a change happens, and only have to do it once, not have to like recalculate and have glitches where it shows the wrong intermediate value and then finds the right value. We don't see that with spreadsheets. We don't want to see that with our Angular code either. Now, I'm not saying Excel was written with signals. I have no idea, but the mental model can be useful to you. So what is a signal? You can think of a signal a lot like a cell in a spreadsheet. It's a box that has a value. But what makes it interesting is it's a box that knows how to tell other boxes that that value changed. And that simple bit of concept is surprisingly powerful. Now, I mentioned this is a synchronous reactive primitive. What we've had for a long time in Angular is observables, which is an asynchronous reactive primitive. What's the difference there? Do signals replace observables? No, not really. They have their own areas. They solve different problems, so they're complementary, and I'll go a lot more into detail on that. So why did the Angular team bring these in? Part of it is to have simpler declarative execution. In cases where it can replace an RxJS pipe, the code's a lot easier to read and write and understand. But the main reason is to improve change detection so that Angular knows what to put on the screen. The way we have by default for change detection and have had since the beginning with Angular is using a third-party library called zones. And the first time you see Angular working with zones, it feels like magic because I can make a change here and then suddenly this other part of the application updates immediately and I don't have to do anything to tell it to change there. And it feels like magic, and it's great until it isn't. And I'll explain more now. So how do zones work? So imagine we have a simple application like this. We have a root component with a couple of child components and a grandchild component, and the user does something to change the child component. The way zones works is it does a tree traversal from the root through the entire application. Not to re-render everything, that would be incredibly expensive, but just to say, I know something has changed somewhere, but I don't know where. Are you the component that changed? Do I need to re-render you? How about you? Are you the component that changed? Are you the component? It has to ask every single component in the application if it has changed, and if so, it will re-render that component. And it is a fast traversal, but it's still, for a large application, a large traversal. And that's not great. A couple other problems with zones. It's a third-party library, so it adds to your bundle. It runs more than theoretically strictly necessary because they just want to be safe for code, for corner cases. So it runs extra times. And then it uses something called monkey patching. Zones actually changes the JavaScript that you have in your browser so that it can keep track of things. And some people have a huge philosophical objection to that. But even if you don't object philosophically, there are technical issues. Things like async await, for technical reasons I don't understand, cannot be monkey patched. So they have to write a whole bunch of code around it to simulate monkey patching on async await, and other JavaScript features are coming that zones will not be able to handle. So it's just showing its age. Angular has always had a second approach for change detection called onPush. And with that, if the change happened at the child, there's still a traversal, but instead of traversing over the entire tree, it traverses from the root to the specific spot that changed, which, for this, hey, that's only half the traversal. For a large application, it can be a tiny fraction, which is great. Couple downsides. onPush is less magic, which means you as a developer have more responsibility to make sure that you know when things need to be re-rendered. Some will happen automatically, but not all. And so you have more responsibility to do it. The other downside, potentially, is the traversal stops at child. So if grandchild is a, say, third-party library component that expects to work with zones, you just broke it. Because it's not going to be told or asked if it needs to be re-rendered, so it won't be re-rendered. So how will Signal help us with this? When you make the change on the child will get re-rendered. That's it. Angular will know that that component has changed. Not like zones where Angular knew a change happened somewhere and it had to ask. It will know that component has changed. But even better, it will know the individual lines in your template file that changed and redraw only those individual lines. This sounds amazing, but there's one downside. It doesn't actually exist yet. They're working on it. They're pulling the pieces together, but it's not fully there yet. So what does it look like in practice after all the hand waving? Back to our friend the sewer component. Again, there's one bit of state here. Manhole open. We're going to change that. Instead of being a Boolean false, it is now a signal. And the way we create a signal is by saying signal, putting parentheses around that false. And now we have a writable signal. So now instead of just being a Boolean, it's that box that has the value false. So in our template, when we want to use it, we say if manhole open, and we get the value out with parentheses, manhole open, show welcome or not. We want to decide what text to show on the button. Hey, manhole, are you open? Get the value out, say the right thing. And then when we click the button, instead of just switching the value, we get the old value with the parentheses and set that back in. So not a whole lot of change, a little bit more code, not a whole lot of change. And I'll show on the next slide why this is actually advantageous. Because this next slide, showing a little bit more of the API. So what if, for that text for the button, we don't want to get the information in the template, which happens a lot. Sometimes if you have complicated calculation, you don't want to do that in the template, you want to do that in TypeScript. So we can do that with a computed signal. So now, instead of doing all the calculation in the template, we have this new signal called button text that is computed when manhole open has its initial value, and anytime that value changes, this will get recalculated. So now we have brought that in, and this is a non-writable signal. We can't call set on it. The other part of it is we wanted to move that click. Instead of doing that in the template, we can do that in the TypeScript as well by using another feature called update. In addition to set, where you can put any value you want in it, type safety taken care of, update gives you a callback where it gives you the previous value, and then you give it what the new value is. And for a button click that's a toggle, it's a perfect use. Give me the old value, I'll convert it and put it right back in. Set and update are both great. Not saying one's better than the other, I'm just showing you both. But now that we've done this, we can look at what actually happens for Angular when we make this change, when full change detection is done. We will initially create our writable signal with a value of false. So that box will have a value of false. And then button text will be created so that if it is ever requested, it will be able to make that calculation. We use the manhole open up in the template. So it grabs that value out and it says, oh, your value is false, so we don't show the welcome. And then it comes to button text and says, all right, I need you to calculate your value. It will call this callback and get the old value and then calculate that we will say open manhole. Then when the user clicks that button, it'll call the update to change that manhole open. And at that point, manhole open is marked as dirty. It doesn't, and that causes anything that depends on it to be marked as dirty too. So it's this box that has, the value has changed, and so it is pushing dirtiness down. So now button text is dirty. And because manhole open is dirty and button text is dirty, and both are used in the template, they can both tell Angular, this template is dirty on this particular line and this particular line. So Angular will know on the next tick, these are the things that are dirty. I need to re-render them. It'll get to those lines and say, hey, manhole open, what is your value? That value is easy. It's just a Boolean, gives it to it. Hey, button text, what is your value? It'll recalculate this at that point after all of the things it depends on. In this case, just one, but it could be more complicated. Recalculate yourself and show it. So we push dirtiness down until something asks for the value, and then we pull the new value in. And that gives us the power of Angular will be able to re-render only the specific lines that need to be re-rendered. We have glitchless performance because the calculation is done once everything that it depends on is already set. And we only have to calculate it once. We don't have multiple cycles for calculation. So that's where the power will come from, which you can't really see in this tiny, tiny app, but that's where the power of signals comes. Now, I mentioned with the computed that is write only. If you want read only, or if you want to be able to overwrite it, you can. This was not part of the original API, but they realized a need for it. So if you have something where you want it to be calculated by default close manhole or open manhole based on this other thing, but you have some reason you want to override that on Tuesdays, it says come in for a party, whatever. You can call set or update on a link signal. So it behaves like a computed until you overwrite it. You can't call a set or update on a computed, but you can on a link signal. So that was in preview in 19 and stable in 20. Another important part of the API are the queries, inputs, and outputs. So traditionally, for all of these, we have used decorators in Angular. And those have worked, but now we can use signals. So we might have had a child, that's some element with a view child that we would get it before, and that would have a value. Now we use a function called viewChild. We use generics to tell it what the type is, and now that is a signal, so anytime there's a change in that view, we can do all of our signal computed, everything else with it. Same with content projection, so content children, we do the same thing. What we use much more frequently are our inputs. So what input would come in before, all right, we have it just as a value. Now our input comes in and it's a signal. So the list is a required input of an array of bad guys. And the selected ID is a non-required input of an ID. And those are signal-based, and we can use this parentheses to get the value out and do it on computed and everything else. Output also changed from a decorator to this function. It's not actually signal-based, but it changed at the same time as everything else, so it'd kind of throw it in. So how does this work with RxJS? So here's an application that Michelangelo wrote to keep track of his bad guys. Initially, it'll load in 10 bad guys. But as you type in the filter, that's an Angular reactive form. As you type it in, that sends that filter text to the backend, and we get a shortened list. And if you click on any of the bad guys in the list, we highlight that bad guy, and then make another call to the backend to get more information to display. The way that looks on the template in an observable-based approach is on the left. So that filtered list is an observable, so use the async pipe to get it out. And let's see, that selected ID, we're going to keep track of the ID. We need to pass that down into the list to know to highlight that list. So that's async pipe. And same with a full selected bad guy, that's an async pipe to pass into the detailed view. And when you click on a particular one, that comes up as an output, so we grab that and we can next it onto a subject. So that's the old way. Now, instead of async pipes, we just have parentheses. We're grabbing the value out of our signal. And instead of nexting onto a subject, we're setting it on a subject. It's a little bit simpler. The TypeScript, there's a lot more going on here. So again, on the left is the observable way, on the right is the signal way. Both of them are going to have a service where we make our calls to the backend. Both of them are going to use a reactive form control. Signal-based forms are coming, but they don't exist yet, but they're coming very soon. But that's where things change. In the observable approach, we have a subject to keep track of the ID, but then when we want to show that list is going to be based on what we type in, that reactive form. So we're going to make a call to the backend based on what's in there. So reactively, we listen to every value changed. As we type, we get that value. We start with the initial empty value. We do a debounce time, so we're not slamming the server. So we wait a quarter of a second until we make a call to the backend. But once we have that, we make our call to the backend, and that gives us our filtered list observable. And the selected bad guy, when we've clicked on one of the bad guys, we have an ID, it's in our subject. We're going to grab that and then do a switch map on it to make a call to the backend to get that information and show it. I'm going to zoom in a little bit for the signal-based approach. A lot of it's the same because there's stuff here that signals can't do. Signals are synchronous. They have no concept of time. Debounce for 250 milliseconds, signal can't do that. Wait for the network lag while that call is happening to the backend or doing a switch map, signals can't do that. And so far, because we don't have signal forms yet, using that reactive form, signals can't do that. That's going to change pretty quickly. So what we do is we do a bunch of this stuff in our observable, grabbing our value changes and start with and debounce time and switch map, do all of that, and then wrap that into signal. And now it's available to our template as a signal. Need to put an initial value on there because a signal has no concept of time. It has no concept of, oh, you'll get a value later. So we need to give it an initial value just as a placeholder. And selected bad guy is actually kind of worse because we're starting with the signal and we're ending with the signal, but in the middle, we have to do observable stuff. So we play this game of, all right, selected ID is a signal, then we convert that to an observable so we can do our switch map call to the backend and then convert it to a signal at the end. This is how we had to do signals when they first came out. Fortunately, there's a better way. Those things still exist, but we should use the resource API. And resource API lets us start with a signal. So in this case, this is going to get a list of the allies instead of bad guys. So we're going to have our list that is going to be sorted either ascending or descending, and we have that as a signal. And when the first value comes in and any change after, that will be passed in through the parameter to the Rx resource. And then that value will be given to the stream part, which is where the observable stuff will happen. All of that will happen internally. It takes care of the switch map internally. So we start with this signal that we pass to it, and what we get at the end is a whole bunch of signals. We get the value signal that has the value. We get a is it loading or not signal. Is there an error signal? What is the current call state? A lot of stuff that otherwise we tend to forget about. It's automatic. So, and in addition to this RxJS place version, there's also resource, which works with fetch for promises. And just so you know, this is still experimental. Between 19 and 20, they changed the API a lot. It's still worth using, but be careful. There's no guarantee that the API will not change underneath you as they are working on it. So what does it look like to use this? So as before, we still need to do a toSignal because the reactive form still starts in observable land. But instead of doing everything in observable land, we're just getting that initial value. So the initial value and the debounce time, that's the only part that's in observable land. And then we give the rest to our Rx resource through the params. It passes that to the stream. It does the switch map and the call to the backend behind the scenes. And then it gives us this filtered list, which is now a resource ref that has all of those signals. And bad guys improved even more. We don't have to play this game anymore of converting a signal to an observable to back to a signal because it does it all for us. So we just have that selected ID, pass it to the stream, and it does all the observable stuff for us. And in our template, it means things that before were just signals are now things that have a signal. So instead of filtered list parentheses, it's get the value from the filtered list parentheses. Not that bad. But even better, we now have the ability on the exact same thing. Does this have a value? I'm not going to show these things until I know it has a value. If so, then I'll show these things. Or, hey, am I loading? Then show a loading indicator. Or is there an error? I can show an error. It's all built in. It's so much easier for us. There's another part of the resource API, HTTP resource. Theoretically, it's the simplest one, just depending upon what you need. In the simplest case, you just give it a URL, like for something that you're calling at the beginning and then never changing it, just give it the URL and you're done. But there's a bunch of other versions. There's a lot of other stuff that you can put in there that I just don't have time to talk about. Again, this is experimental. And an important thing to know, these resource APIs are really, really cool, but you can only use them for gets if you're doing an HTTP get. Because internally they use switch map, which means if you're using these for mutation, it's possible that some of your mutations are going to stomp on each other and not actually happen in the database. Switch map will cancel calls. So we don't have this neat facility for a put, post, delete, that sort of thing. They're working on it, but it doesn't exist yet. Use these for your gets. The last important part of the API is side effects. So the situation where for observables, we would do a subscribe, and then in the callback, you can do whatever. We now have this effect that will take a callback. So before we'd have the observable of filtered text, we could subscribe to it. And then in the subscription, we would get the filtered text and could update our query params or whatever. We do the same thing now by getting the value out of the filter text. The important thing here is in an observable, if you manually subscribe, you have to manually unsubscribe because of memory leaks. You don't have that in signals. So we have these two things. Which do you use when? Here's a tweet by Ben Lesh, head of the RxJS team. Use signals for state, observables for events. It's pretty simple. The opposite is silly bad. And this is actually kind of why NGRX and sometimes RxJS got a bad rap. It was being used for state, which is not what it was designed for. It was designed for event handling. Signals are better for state. And there's now NGRX that is based on signals, which is outside the scope of this talk, but it's really awesome. So when to use each of these? Are you doing something signal-based? If not, just a regular function. If so, are you setting a read-only signal? If so, computed. If not, are you setting a writable signal? Okay, use a link signal. If not, are you doing an async operation? Use the resource API. Otherwise, use the effect. Don't reach for the effect first. It's kind of the last choice. So the roadmap of this is from a presentation that core member of the Angular team, Alex Rickenbach, gave at NG Glühwein in Austria a couple years ago. At the time, only signals was done. Since then, they've done signal-based I/O, the inputs, outputs, Zoneless on push, that is now the default. They're still working on fully signal components and full signal change detection. So things are still to come, but it's in process. The first version of this was in developer preview in 16, mostly stable in 20, not the resource APIs. And things are coming. Signal-based forms are in preview right now. Really early version. Signal-based components, signal-based, the full change detection, routing, all of these APIs are going to be signal-based in the future. And those are the 4 big areas, but there's a lot more that has happened. There are faster builds with Vita and ES build. Server-side rendering and incremental hydration is a lot better. Let lets you create variables in your template. There are a whole bunch of migration schematics for all of these things. HMR means that when you make a change to your template file in your editor, it automatically updates in the browser and doesn't even need to recompile. It's awesome. There's a whole new website, and there's a lot more. You can follow these links to read everything else. And with that, I hope that you are enjoying what's new in Angular. Thank you.